Hello, good morning, Professor and TA. This is my PowerPoint presentation of Introduction to Systems Engineering, and this is the final report. The topic being satellite communication, and I'll be majorly focusing on Starlink. So let's begin. So these are the contents of today's presentation. We'll go through the introduction, the satellite communication, the Starlink, the system engineering phases, the concept development, the need analysis, the concept exploration, the concept definition, engineering development, progressive improvement, technological model, convergence and scrutiny, fostering, effectuation, challenges, references. So let's begin. Introduction to Systems Engineering. What is systems engineering? Systems engineering is a process that we can use to develop something that is too complex or sophisticated to design and build as a single entity. In simple words, it is about thinking about a system as a whole and trying to understand the various interactions the system has with the external environment and also the interaction that system has within its own system with different components. Systems engineering is the guided engineering process to implement a particular system and meeting the needs of the project. So, systems engineering is relatively a field which is used to understand the environment, understand the use cases of the system with respect to the environment, and it mainly deals with the big projects such as electric cars, building maybe a water drainage system for the entire city, or maybe for the present situation, satellite internet constellation. So, satellite systems engineering is a department which involves a linkage or interdisciplinary field which joins two or more and many more departments to make it one working system. For the present topic, now let's understand what is satellite communication. So, firstly, let's understand what is satellite. A satellite is a smaller object or a body that revolves around a much larger object or a body in space in a well-defined path. So there are two different types of satellites. There are natural satellites and there are artificial satellites. Artificial satellite is Starlink, which we are about to study. And natural satellites are the Earth and the Moon. So Earth revolves around the Sun and the Moon revolves around the Earth. So these are two natural satellites. So if communication takes place between any two Earth stations via a satellite, it is called as a satellite communication. So the frequency with which a satellite communicates from Earth is known as the uplink frequency. Similarly, the frequency with which the Earth communicates from the space station to its base is known as the downlink frequency. So let us now understand why satellite communication. Why do we need to study about satellite communication? What is the use of satellite communication? What has been the processor of satellite communication? Why has satellite communication come into existence? That we are actually doing a paper on this. For this, we need to understand the different types of communication or propagations. So, these are the various different types of communications which are involved. The ground wave propagation, sky wave propagation, and scattering wave propagation. All these forms of communications or propagations are dependent on the Earth's curvature and the ionosphere for their operation. So, satellites are located at a height above the Earth's surface, where the communication between two stations happen via the satellite. In this method, the Earth is not a mandatory requirement. The communication does not depend upon the curvature of the Earth. So this is why a satellite communication has come into picture. The main reason being that ground wave propagation or sky wave propagation or these scattering wave propagation, which uses the Earth's atmosphere and ionosphere as their source of propagation, are relatively slow and cannot traverse longer coming distances as compared to the satellite communication. So, these are the points which have to talk about the case study of satellite communication. This semester we are doing is Starlink. So, as you can see in the photo, these are the satellites which have been launched in the LEO stationary satellite, which is about 210 kilometers above the Earth's surface on May of 2019. A line of many satellites have been launched, as you can see on the screen. So this is quite amazing. What's that Starlink has achieved? And yeah, let's study in detail about what this has to do. So let's understand more about Starlink. What is Starlink? Starlink is an internet constellation operated by SpaceX. SpaceX is again an aerospace manufacturer and a space transportation company. So Starlink aims for providing global coverage and promises to deliver high-speed broadband internet to location where access has been unreliable or completely unavailable. So about still 37% of the world are not connected to internet, and this is a major market potential tap for Starlink. So Starlink has used this situation and has made beautiful business of this potential growth. So Starlink, the FCC, which is a federal court consumer, has approved Starlink to launch at least 12,000 satellites, and deployment will be done in 9 years. So the long-term goal of, according to Elon Musk, is about 42,000 satellites, which is a humongous amount of satellites being launched into space. So technically, the Earth will be covered with a constellation of satellites in the LEO orbit, providing internet to each and every location, even though the location is unreliable, or maybe the access has been unreliable or completely unavailable. Also, as we can see, the Starlink operates in the lower orbit of the Earth, that is about 1,200 kilometers or 250 kilometers away from the surface of the Earth, which helps in reducing the latency as the distance to travel from transmitter to satellite and satellite to receiver is minimized. So this is a major game changer, as the constellation of low or Earth orbit were first conceptualized in the mid-1980s for strategic defensive operations, but later entered bankruptcy because of dot-com bubble, which we were all know what happened in 2000. And also it is very expensive to launch satellites into space. Satellite Starlink, on the other hand, has a major advantage because its parent company, SpaceX. With SpaceX, the main job of SpaceX is to launch satellites into space. The Falcon 9, which is used for the launch of these satellites, used a small rocket. So it means launching satellites into space is not a problem at all for Starlink, as they have already converted, all thanks to SpaceX. So let's go to the next slide. So given here is the system engineering phases. This is a V model. It is a common graphical presentation of the system engineering life cycle. The left side represents the concept development, composition requirements of the physical entities that can be architected, and the right side involves the integration of these architects. So the left side involves the concept development or the requirement and the system architecture, and the right side involves the evaluation, testing, integration. And all this is very important to the V diagram which is used, which is always as a reference in developing any system engineering project. So going on to the next slide, concept development. So this is one of the most important and one of the most earlier stages in system engineering life cycle. There are various set of activities that are carried out which questions the existing system performance, weigh out the alternative options. They prioritize the operational needs and challenges and select a preferred one based on the decision pool which you are having. So basically, a stakeholder comes up with you with an idea. You make different concepts out of those ideas. Try to make out the different options. Try to understand the situation. Try to understand if a present technology or a present device is already there which is doing justice to the system, and if not, then we get through the next process. So we understand what is the concept, we understand what the concept is we are just trying to develop the concept in this stage. So it involves analyzing the plans of the system, understanding the interactions involved, especially externally and also internally. So concept development can be subdivided into three parts, which is need analysis, concept exploration, and concept definition. So moving on, the primary objective of need analysis is to show that there is a need, there is a valid need and a market for the proposed system over the existing ones. So this means that is by satellite communication. Why do we need satellite communication when we have ground with the propagation? We do need satellite communication because the ground wave propagation cannot travel longer distances and is relatively slow. So that's yes, there is a need, and yes, there is a market potential. So this is the one of the major need analysis. So obviously the new updated version of the system must provide a better value than its legacy system or its project predecessor, while withstanding the threshold limits. So need analysis can be done with respect to two. It can be either a technological driven or it can be the need driven, technology driven, which is basically there has been advancement on the previous legacy system, and as live as technology updates every year, we need to update the system based on the technology. Need driven system, focusing on developing a new system as there are obvious flaws in the present one. So these are the two major concepts of the need analysis. Either it is technology driven or either it is the need. So need analysis for Starlink is the primary objective of Starlink. It is to provide internet connection to rural areas where connection is either unreliable or unavailable. So the main objective of Elon Musk and of Starlink is to provide internet router from space. So Starlink has made sure that this is an achievable goal, and is building of internet from space is a long-term goal for Starlink. Starlink has come into existence because of both technology driven and need driven as compared to Viasat and Usenet. Starlink is more efficient and is cheaper in comparison to manufacture. Moving on. Concept exploration is the subphase, and it uses the output from the need analysis subphase and continues on top of it. It converts the operational viewpoint of a system to an engineering viewpoint required in all system engineering phases. This means to provide an array of selections available or an option pool which can be materialized into concepts that can be evolved into a physical model of the system. This the main concept of concept exploration. So there, as you can see, are various parts into the operational requirement analysis, performance requirement analysis, implementation of the concept explanation, and performance requirement validation. So there are 4 to 5 stages involved in concept exploration, with each phase gives out an output which is an input to the next phase, and that input to a phase gives out a prior output. So each phase is important to each we clear and the phase to go to the next phase. Concept exploration for Starlink operational requirements were analyzed for starting to provide internet connectivity across the world. Tintin A and Tintin B were launched into space as prototypes, which helped in later refining the design and understanding the interactions of the satellite. These readings and the requirements were required and communicated to the stakeholders as they had to know the importance of the prototypes, how the prototypes have done, that is Tintin A and Tintin B. So, moving on to concept definition. Concept definition, as the name suggests, entails the selection amongst the option pools that is the best alternative or the candidate system concept after conducting thorough trade studies, and trade-off's final decision is based on the following criteria. 1 is operational performance and capability, 2 program cost, 3 program schedule, and 4 risk involved. So a system at this stage is picked out of the option pool based on these 4 parameters. So these 4 are the functional parameters which a system engineer has to look out for and select the best system which is working for the concept. The concept definition for Starlink is so the satellites were powered with laser link, that is mimicking the fiber connection, mimicking the optical fiber communication that happens on Earth and communicating in space, relaying signal satellite. This led to belief of better long distance communications without the interference of the Earth curvature. The satellites on space will be orbiting around the Earth in a fixed path, avoiding debris with the help of debris collision. Protective data that is being fed to it so that this does not even satellite has to fail or a law, maybe a collision. The next is the engineering development phase. The engineering development stage is the second most significant stage and it comes after the concept advancement stage. It includes chipping away at the top of the needs which were broken down and finished in the past idea development stage. So, in this stage, we will design and assemble the plan and foster the framework which is used for making a model for the system. And this involves working on the needs and the requirements which were discussed earlier in the previous development stages. So, first, a prototype is created and the rigorous testing and validation is done with this prototype under different situations and environmental conditions and circumstances, especially with respected to Starlink making the system production ready. So, there are 3 stages of engineering development. Number 1 is progressive improvement. Number 2 is technological model. And number 3 is convergence and scrutiny. So, as you can see, this is one of the most important diagram of the engineering development subphase. So, system functional specification and the system defined concept of the previously defined subphase act as the input of the progressive improvement, which gives out outputs as a technological model specification and validated development model. So, each subphase has given out inputs which act as each subphase outputs after a certain process which acts as input to this prior phase. For example, as you can see, the technological model specification and validated development model act as the input to engineering design phase, and later when they are going through this process, they give out convergence and scrutiny and engineering concept, which are the outputs of this stage. But inputs far and the right after the convergence and scrutiny is done when we get a system which is ready for production. We get a system which have almost ready with the specifications. Moving on. So, starting being such a sophisticated yet complex system. So, this topic is progressive improvement. The satellite release in the LEO orbits of the Earth interface issues are bound to happen. So, let's understand the progressive improvement phase of starting. So, the main objective of this development phase aims to solve the risks which were involved and discussed by performing analysis, simulation, development and testing of the proposed prototype. So, we have to understand that with such a sophisticated Yet, complex systems which Starlink provides, providing internet satellite communication just through the space by relaying signals by laser communication, software interfaces and software issues are bound to happen. But however, there have been many situations where the Starlinks have stopped responding, but the software team of the Starlink has been up to it and they provide a software update to push the system into normalcy and debug and fix the issue. So there are certain interface issues which happen now and then, but we have to make concern of them and we have to keep a constant check. And as far as Starlink is concerned, every week for 60 satellites that have been launched into space, there are every week a satellite software updated and pushed out of from the space station into the space. So usually after the update, the satellite is back to working. So every launch of 60 satellites into space also means around 4,000 Linux computers. The reason being SpaceX satellites and SpaceX rockets and Starlink use Linux operating system. So the second one is performance requirement. So the geomagnetic storm, which has recently been caused due to the mother nature, has increased the temperature, that has increased the heat and increased the atmospheric density. So the geomagnetic storm has increased the heat and also increased the atmospheric density. So the GPS suggested that with the increase in density and heat, the atmospheric drag also increased by 50%. So about 40 out of 49 satellites have been launched into space but deorbited into Earth by command or by themselves have entered the Earth due to the much atmospheric drag. The Starlink team has commanded the satellites to enter a safe mode, which will allow the satellites to fly on the edge just like a sheet of paper, minimizing the amount of drag with the help of modulation simulation. Feeding of space debris information into satellite. None of the satellites were damaged, but was a major learning curve for the team. Suppose this geomagnetic storm, which I think happened in Texas, the Starlink team was quite well equipped as how to deal with the geomagnetic storm and how to deal with any other environmental issues externally. Number 3 is collision avoidance system. So SpaceX has launched many satellites into space with the expectation that the information is being shared right from the deployment to the end of the life cycle. This information of the satellite is actually being shared persistently with the US Space Force, Leo Labs and different administrators for following the crash aversion screening. As you can see, this is what I have explained about. The next one is the technological model. Okay, so the first draft model, Starlink has fabricated and tried more than 60 of Starship's Raptor engines, amassing almost 30,000 seconds of total test time and about 567 motor turns. So there have been 6 suborbital flight tests for this and 150-meter jumps and 4 high height flights. So there was a satellite SN11 which has been launched into space with the help of 3 adapter engines. Each of these engines shutting down prior to the vehicle reaching apogee, that is the maximum height. So we have to understand the concept of prototyping test flights or prototyping are all about understanding the further development on the new errors found. So for example, S11, as you know, was a satellite launched by Starlink, but it had a bad landing experience and also unscheduled disassembly. So Starlink will look forward into the matter that they have adjusted the certain specification and parameters and make sure that such a catastrophe do not happen. But yes, it is very important that system is ready before the production. So vulnerability amelioration, it's important to understand precisely. It re-enters how the Earth's atmosphere at a hyperspinning speed. SpaceX is the only launch service in the world that can do this. The major game playing facts of Starlink to minimize the risk Starlink is trying to make. The satellite is visible to the naked eye. So this is possible, you may ask. It is done by altering the way of the satellites, especially in the operational altitude. So this is a major software update which has to be updated from the base. So within the first week of the launch of the satellites, the Starlink is trying to make the satellite visible. There is also argument that Starlink produces a lot of light. So Starlink is also trying to darken the satellites on the contrary to reduce the risk on astronomy. Okay, and so you can see Starlink team is approaching this problem by adding a deployable visor from hitting the brightest part of the spacecraft. So as we can see, the next phase is the technological model phase. So technological model phase is the main objective of the design phase. It is to build a model derived from previous advanced engineering stage. And this stage aims to create a more engineered prototype with the sharp edges and a more concrete system with well-defined requirements. So we have to understand why Starlink design was successful. Starlink design was successful because of its limitations. Due to these limitations, the system engineers and a team of Starlink have put this limitation in consideration and built up a system which may be overpower the limitation. So what were these overpowering decisions? Number one becomes mass production at a cheaper cost. Number two, they were equipped with Hall thrusters of krypton. Number three, air traffic. Number four is airspace debris. These two are in caps lock because there are two major issues: air traffic and space debris. And last but not the least, satellite makes use of inter-satellite communication phased array beamforming and digital processing technology in the Ku and Ka bands. So we have to understand, due to the worries provided by the space environment, SpaceX decided to deploy 60 satellites at a relatively lower altitude of 550 kilometers in the year 2019. Now, early satellites lacked laser connections in the later half of 2020. The interstellar laser links underwent a successful testing, as this was a major requirement for the fast internet connection. Laser links were mimicking the optical communication patterns of the Earth in space. The satellite has also host optical trackers to detect the space debris, allowing the spacecraft to automatically avoid the collisions and other objects in space. We also have to understand a major important thing, which is satellite launching and then the failing, but then hitting the Earth surface. Coming back in the Earth surface is actually a good thing. Starlink engineering team has done various testings on the prototypes to actually allow the star satellites to deorbit itself, either after its life cycle or after a failed mission, to come back to Earth surface and not remain on the space as a vacuum, as this satellite remains in space can act as an obstacle to other satellites, creating more havoc and more danger. Okay, this is one of the most important diagrams of technological model flowchart. So as you can see, there are stages of progressive improvement, technological model, convergence, scrutiny, engineer. Okay, so progressive improvement on the inputs of the concept definition and the concept explanation, as after progressive improvement gives out technological model specifications and a validated model as the output. So these two act as the input for the technological model, and these two, when acted upon technological model with the due process, gives out as an engineered prototype and also gives the convergence and scrutiny plan, and these two act as an input for convergence and scrutiny. This is the final subphase of the engineering development phase. The objective of this phase is to match the intended design and the actual design, and also to match the use cases of specific design. Usually this phase not skipped if all the phases of the engineering phases are flawlessly designed. But in such a huge project, Starlink or building an electric car or deploying a water system model for a city, we require the integration, that is the convergence and scrutiny. Every step needs to be considered, for like every single main miniature mistake can lead to a total loss of the project, resulting in downfall of billions of dollars. So yes, the creation of the mega installation opens up new possibilities for the expansion of the internet into space. There isn't a lot, so let's understand the integrate the space and terrestrial networks. So this is what Starlink and many such satellites which are released into the LEO satellite orbit and GEO satellites orbit into the have all promising to offer. That is a pervasive low latency, high throughput internet service on a global scale. This is due to the rapid evolution of the aerospace industry. This is the only reason why it is anticipated that ISDN, which is integrated space and terrestrial networks, can be well developed and evaluated. prior to the launch of satellites because of the high cost of manufacturing and launching and updating of LEO mega constellation. Existing methodologies for testing, assessing, and later understanding a network functionalities. A protocol can be typically classified into three categories, which is live network, network simulators, and network emulator. This is as far as concerned as a network, I mean connectivity, internet connection is concerned. This is how we can evaluate. The basis of evaluation is three. Number one is the live networks, number two is the network simulators, and number three is the network emulator. So network simulators, network emulators, and live network, these are the three main causes for the internet connection which are happening in the middleware, be the software, be the hardware. These three are the main reasons why internet is possible via the Starlink or for any other matter, as in fact the satellite, which can call itself as an internet providing constellation. The creation of the mega constellation such as internet opens up new possibility of extension of internet into space. But this comes with a heavy integration problem, as they have to integrate various outside the system and provide a seamless internet connection. However, we only believe that tackling the issue prevents us untapped potential for our community-driven effort. So every time there is an integration issue, it's a matter of fact that we have to solve for the further increase the area and the bandwidth of the internet providing constellation. So it's very important that we have to integrate and evaluate every step, especially in the matters of the huge project which involves billions of dollars. So we have come to the last part, which is fostering. The main objective of fostering is to incorporate the design and engineering from the previous engineering advancement stage into the real components. Typically, the implementation phase comprises of three parts, which is hardware plus software and also the assembly. So when the system is actually set up for production, we have to make sure the system is ready in terms of safety, reliability, and also affordability. So there were many use cases of Starlink production. The first use case being the military capabilities, which is the data transfer, combat management, tracking of missiles, targeting weapon navigations, and even ground support. So these were all maybe the 7 levels that make up the national defense space architecture. So NDSA has tied up with Starlink in order to, because the budget friendly and rescue and technology with which Starlink uses is much sophisticated. It has controlled mesh network, laser terminals, and along with that, it's a contract signed with a Starlink. So it's a request from the Ukrainian government to replace the internet service, and they were essentially abandoned during the 2022. Elon Musk declared that on February 26 that the Starlink satellites have been started to operate up and over Ukraine, providing internet to the Ukraine. So these are the main use cases of the production and the main objective of the production of Starlink satellite. The next is effectuation. Effectuation is the final component of the entire life cycle of the system engineering project. This also marks the end of the system engineering's role and responsibility, but on the contrary, this phase also means to provide the continuous support and maintenance work of the system post-production when it has been deployed. That is the main objective. So in a way, the physical responsibility of system engineer, whether the system is actually working in the working or not, that part is done. But this part is where the maintenance comes into play. Maybe the system engineer is directly involved, but this is a part of the system engineering. So this subphase goal is to continue the product's life cycle by offering support and maintenance to the system after it has been deployed. To achieve this is all well organized, planned timely upgrades and repairs if necessary, as the product, we all know, deteriorates over time. So in this case of Starlink connecting the global population who are still unable to access a decent broadband service remains a key part in the United Nations Sustainable Development Goals. So the values can be imputed to the model to provide an approximation and a capacity and a cost of connection, which were the internal, which is publicly accessible based on the financial statements, public financial statements. So to improve the current simplification, future study can focus on the problem of non-linearity with respect to satellite resources. That is one aspect which we can further look over. But we also have to understand that US Air Force has chosen Starlink, which is why, according to the US Air Force, the only low Earth orbit satellite that offers service to Europe and Africa is Starlink, and additionally it can provide mobile services to EUCOM and AFRICOM responsible areas. So this is why Starlink has been a major game changer and the major player in terms of internet, broadband, satellite communications, and other businesses are trying to build LEO and also trying to build medium earth orbits and geostationary satellites in contrast to the rival network. You still think in infancy SAS Starlink was well established as a LEO satellite and 1350 satellites in space. It's all participated in the conflicts between Russia and Ukraine as an evidence of its mettle. So yeah, there has been a long-standing operation and a long-standing support from the US. So one of the most important challenges faced by Starlink is the Kessler syndrome, that is a satellite collision that might lead to amount of junk in the orbit around the Earth. The second one is the cost of launching satellites into space. So obviously there has been a lot of the cost of launching satellites. With the help of SpaceX, an astronomical company, used the space transportation, this job has been made easier for Starlink. I would say the third one is astronomical impact, that is light pollution. And this is one of the major challenges faced by the scientists, and many of the astronomers were actually going against starting seeing that, there has been a lot of light produced, which is not good for the nature. And so Starlink has also dealt with that by adding a visor in the field, so which will automatically reduce the brightness of the major part of the Starlink satellite. There have also been many integrations and evaluations issue, which we would they weren't many failures, drawbacks in each of the satellite. This were the space. There were the times when satellites were not communicating. But one thing is for sure, that the team of Starlink has been going through thick and thin and provided and are really good at fixing and debugging the issue, provided that the satellite stays into space and responds to the satellite. So has given the information about present situations. The Starlink team has acted upon it and has given software update, pushed into space but the later, and made the system into normalcy. So there are challenges. These are the challenges faced by the Starlink in order to make itself more viable in the competition. But yes, so with this we come to the end of the presentation. Thank you so much for listening patiently for me.